All right, so let's take a look in section 4.4 at how to factor trinomials. Now, these are trinomials that are going to look like ax squared plus bx plus c. So we have a lead coefficient here that's other than 1. We saw what to do if it's a basic trinomial where it's just x squared plus bx plus c. Now, first of all, we always want to look for a GCF first, but if we can't do that, and we're left with something that looks like this, we have a few different options. 3 options that we're going to look at are guess and check, slip and slide, which I'll talk more about after, and master product, which is the one that I think is the best mathematically and I really like. So the first option, though, really is a guess and check method, and it's an intelligent guess and check. We're not just kind of picking random things to work with here. We want to look at a polynomial like 2x squared plus 5x plus 3, and think about reasonably how could we possibly multiply two things and get that. So in order to get that, we're typically going to have 2 binomials. So I know it's going to look something like this. I'm not sure exactly what's going to go in there, but I think about how can I possibly get what I need here. Well, the only way I can multiply and get 2x squared is if I have a 2x multiplying an x. I know that ultimately when I factor, I should be able to multiply back out and get my original problem, so that's a good start. Now I think about how I can multiply to get the 3 at the end, because if we think back about FOIL, the first times the first is going to give me the 2x squared, the last times the last will give me the 3, so the only way that I can think of to get that is 1 times 3. All right, and because I'm multiplying to a positive 3, I know that I have to be dealing with 2 signs here that are the same, either both positive or both negative. So I look to the middle and it's a plus, so I'm going to say then that's going to be a plus 1 and a plus 3. Now again, this was guess and check, so I've guessed that this should work. I'm now going to test this out by multiplying. 2x times x is the 2x squared, 1 times 3 is the 3. That's fine. But when I do 2x times 3, that's 6x, 1 times x, that's 1x, 6x plus 1x is 7x. That doesn't match this right here. So I've done something wrong. Well, the best thing that I can do is say, I know that I have a certain rule about multiplying to the 3, so let's see if I can just switch this 1 and 3 around and see if that makes a difference. So now I'm going to do 2x plus 3 and x plus 1. My first and my last are still going to give me the 2x squared and the 3 that I need. But now when I do the outside, that's 2x, and the inside, which is 3x, that gets me to 5x. And that's a good thing. That's really, really helpful. And I'm done. I'm done. That's all I need to do there. So I will repeat this process for the next problem. 5m squared minus 17m plus 6. I know this is probably coming from a couple of binomials. And the only way I can think of to get 5m squared is 5m and m. So now when I'm looking at this, I'm going to try out a couple of different options because I have different ways that I can multiply and get 6. I could do 1 times 6. I could do 2 times 3. All of these are different options, and it means I'm going to have more than one thing that I might have to try. The other thing to think about here is inside. I don't know what symbol I'm going to use. The fact that it's a plus 6, I'm multiplying to a positive 6, tells me that I must be dealing with the same signs, and I look here to see that it's going to be a minus. So I'm going to put 5m minus and m minus. Now I can try anything that I want. Maybe I'll try 1 and 6 first. So I'll try the 1 and the 6. I know the first and last are going to work. 5m times negative 6, though, is negative 30m, and negative 1 times m is negative 1m. That outside, inside, those combine to negative 31, which does not match the negative 17 in the middle. So I know that that's not the result that I want. Try to erase that instead. There we go. So I could switch them around. I could try 6 and try 1. 5 times negative 1 is negative 5. Negative 6 times m is negative 6. That's negative 11. Still doesn't match. So the 6 and 1, no good. Got to get rid of those. Now I'm stuck on the 2 and the 3. And I just keep on trying until I get the one that I really want. So maybe I'll just try 2 and 3 in this order. If it's not that, I got to try 3 and 2. Again, the first and last will work. You see it's 5m times m is m squared. Negative 2 times negative 3 is positive 6. But now outside inside, negative 15m, negative 2m. That's the negative 17m that I need. So that one's done. That's it. That's all there is to it. I don't need to try another one because there's only one way to do it. Then I have 6y squared minus 5y minus 4. This one is a pain because there's multiple ways that I can get to 6y squared, and there's multiple ways I can get to negative 4. And the fact that it's a negative 4 tells me I have one positive and one negative. So this is a mess. All right? Take a minute, pause the video, see if you can figure out what the correct combination should be, and come back and check your work. Go ahead and try. All right, let's see how you did. So after what maybe was a lot of trial and error, you should have ended up at 3y minus 4 and 2y plus 1. Certainly you could have those in the opposite order, but the negative does have to be with the 4. If you happened to try 3y plus 4 and 2y minus 1, what you'd see is you'd get the same thing as the original when you check it. You get the 6y squared and the negative 4, but you'd have a positive 5y. If you're ever off when you're doing your check by just having a negative instead of a positive or vice versa in your middle term, just switch the two signs in your answers, and that would be all that you would need. So that's what you end up with there. Guessing and checking, it's a good process if you have convenient coefficients, especially numbers that are prime like 2 and 3, or even 5 and 6, which doesn't have a lot of different ways to multiply, and 5 is prime. When you have something like 6 and 4, especially when there's negatives, there's so many different ways that you can multiply to get those, it becomes difficult to select the one that you really want. So let's learn a couple of other ways that are a little bit more algorithmic, straightforward, that you can use all the time. All right, this next method is called slip and slide. And I'll be honest, it's not my favorite method, but it does work if you can get good at it. It seems like a little bit of kind of like this math magic, a little bit of a trick, but hopefully it makes sense, and it's something you can use, but I really don't want you to use it all the time. It's just something that you can use to, if you really get stuck. It's called slip and slide, just kind of a funny name. We're going to start off by slipping the a to the end of the trinomial and multiplying by c. So that's taking this a, which is 4, slipping it to the end and multiplying by c. That's going to turn this into x squared minus 19x minus 20. So we've done the 4 times the negative 5 to get negative 20. Now that's a polynomial we can very easily factor. That's step 2, is to factor this new basic trinomial. We know we're multiplying to negative 20, which means one's going to be positive, one's going to be negative. We get to start with our x's. And because we're multiplying to negative 20 by adding up to negative 19, which is negative, the larger of these two numbers is going to be negative. So that's going to be an x minus 20 and x plus 1. So now that we've done that, we're going to take our two constants, the negative 20 and the 1, and we're going to divide each of them by what we originally slipped, the 4. So I divide each of these by 4. Just the negative 20 and the 1. I now want to reduce each fraction. So that's going to be x minus 5 and x plus 1/4. So we've reduced the fractions. Now I have to slide any remaining denominators. That's the slide, not just the slip. In this case, I just have 4, and I slide it in front of the x in that binomial. I have no denominator left in the first one, so that just stays as x minus 5. But then the second one becomes 4x plus 1. And I'm actually done. That's all that I have to do. You can see that if you take x and multiply by 4x, you get 4x squared. Negative 5 times 1 is negative 5. So first and last work out. Now it's outside inside. X and 1 is 1x. Negative 5 and 4x is negative 20x. That combines to be negative 19x. So that's a way you can do it. You can just use this slip and slide method. Again, it's not great, in my opinion. It seems like it lacks a lot of kind of real strong math, but it does work. You just have to be careful about doing it the right way. A lot of people will forget to slide after the original problem, and make sure that you reduce properly ahead of time too. If you want more practice, go back and try doing the last problems that we looked at using this method, see if that helps. All right, let's try another method. This other method has a lot of different names. I think it's the best mathematically. It shows us a lot of different things that we have to be careful about. It's called master product. Some call it area process or area method. But you'll see there's a couple of different ways we can organize our work even within this. So we're going to start off the same way, almost as if we were doing slip and slide, but we're just going to write a little bit differently. I'm going to start by multiplying the 8 and the negative 3. And I'm going to put that product, which in this case is negative 24, at the top of an X puzzle. So I get the negative 24 there. And I'm going to take my coefficient of B, my coefficient of Y in this case, but what I called B before, in this case negative 10, put this at the bottom of the X puzzle. So this looks similar to how we would have solved a basic binomial, just like with the slip and slide method. But again, I'm not writing that other polynomial yet. So I think about what two numbers multiply to negative 24 and add up to negative 10, and just make sure we're paying attention to negatives. We get negative 12 and 2. So now what we have to do is we have to write this original problem, this original trinomial here, actually as a polynomial with 4 terms, and we're going to use the negative 12 and the 2. So I'm going to start with my 8y squared. I'm going to end with my minus 3. But I'm going to rewrite the negative 10y by using negative 12 and 2. It doesn't matter which order I'm doing this in, so I'm going to say negative 12y plus 2y. You can see that I've used those two answers to my X puzzle as coefficients of y, and if I combined like terms, that would bring me back to my original problem, which I don't want to do. I don't want to go back to the original problem. Now it might seem weird, why would I bother doing this when all it's going to do is make the problem more complicated? Well, I actually could do something called grouping here. If I look at the first two and the last two as pairs, I can often use a GCF. So 8y squared and negative 12y have a GCF of 4y. And in parentheses, that would leave 2y minus 3. Plus, looking at the next two, the 2y and the negative 3, they have nothing in common. So their GCF is just 1. And then it's going to seem weird to even do this, but I'm going to write it as 1 times 2y minus 3. The reason I do that is now you hopefully notice 2y minus 3 is repeated. So I treat that as an entire common factor, pull that out in front just once, I don't square it. And then what remains comes from the 4y and the plus 1. I write that in my other binomial, and you can see that I now have it completely factored. If I multiply out 8y squared minus 2y, plus 2y and minus 12y is minus 10y minus 3. So it works perfectly. That's all that I needed to do. Again, this is just a process you can use. I think it's the best mathematically. I'm going to show you a way now that you can organize your work, and hopefully that will help you keep track of this, again, using the same general process. All right, so let's try this again, just looking at it with a slightly different way to organize it, using a Punnett Square, kind of a reverse process from when we did multiplication before. Again, this is just an organizational tool. You can kind of use any of these, just whatever's going to make it the most beneficial for you. So, start off by taking my 6 and my 2, multiplying them together. That gives me 12. I'm going to put that at the top of an X puzzle. And I'm going to put the 7 down at the bottom. And from the X puzzle, I look for the numbers that multiply to 12, add up to 7. That's going to be 4 and 3. And so I'm going to use a Punnett Square to keep this organized now. So I'm going to draw my Punnett Square here. And I'm going to take from my original problem the 6k squared and the 2 and put that in the top left and the bottom right. So I have a 6k squared here and a 2 down here. I now take the answers from the X puzzle, the 4 and the 3, and I put them in the remaining 2 boxes. The order does not matter here. 4 and a 3. And I've got to put the k on them just like I did when I was doing the other type of a grouping. So if you notice now, these 4 terms, if I combine them all, we just come back to my original problem. So this, you can see the connection to what we had before when we multiplied using a Punnett Square. So now I look down each column and across each row to figure out the GCF of each column and row. This is kind of like our grouping that we did before. Our first column is 6k squared and 4k. What do they have in common? That's a 2k. What do 3k and 2 have in common? Nothing. So in that case, I just put a 1, and it's a positive 1. Coming across the top row from left to right, 6k squared and 3k, they have a 3k in common. And 4k and 2 share a 2. Well, now all I have to do is take the top of that, the 2k and the positive 1, to make that 2k plus 1. And then take the side, 3k and a positive 2, to make it 3k plus 2. And that's my answer. You can check it. It works. So again, it's just an organizational tool. It's something that works. If we're ever in a situation where none of these are working or we can't find a solution to these X puzzles, we might have a prime trinomial. That definitely happens. If inside our Punnett Square here we have any negatives, then we might take out a negative on the top or on the side. It basically depends on what you're coming to first. So as you come down from top to bottom, or you come across from left to right, if the first thing you come to is negative, which would just be here or here, that's when you'll take out a negative. Just make sure that it multiplies back out to the original, though, and you'll be fine. So I suggest you try all of these different times. You know the answers are to each of these problems. Try them with different methods and see what works. Hopefully this makes a lot of sense. Thank you.